Hello students, how are you? Hope you are doing well. Now the question is, a proton with kinetic energy 1.3384 into 10 to the power minus 14 joule moving horizontally from north to south enters a uniform magnetic field B of 2 millitesla directed eastwards. Calculate part A, the speed of the proton, part B, the magnitude of acceleration of the proton, part C, the radius of the path traced by the proton. Take Q upon M ratio for proton is equal to 1 into 10 raised to the power 8 coulomb per kg. So the problem is based on the topic magnetism or the magnetic field. Few basic concepts are used here. First one is the relation between kinetic energy, mass and velocity, that k equals to half mv square. Second concept is used as the mechanical energy is equal to the magnetic form of energy, or in other word we can say that the mass times acceleration, which is force, is equal to the QVB, the magnetic force. Basically, this is the balance of force. So, balance of force, mechanical force provide the magnetic force. So, second concept is used here. The third concept is the radius. It is based on the formula for the particular charge carrier. If it enters into the magnetic field, it traces the circular path, and the radius of the circular path is given by mv upon dq. So this is the formula used for solving the third part of this problem. Now let us solve one by one. So part A. In part A, the speed of proton is asked. So from this particular formula, we can say that V is equal to 2 times Ke by m and the square root of it. Now here, the value of Ke is given as 1.3384 into 10 to the power minus 14 and multiplied by 2, and the mass of proton is 1.67 into 10 to the power minus 27 kgs, and taking the square root of it. After taking the square root of it, we get this value as nearly equal to 4 into 10 raised to the power 6 meter per second. Now for the second part of the problem, it is asked that the magnitude of acceleration of the proton. So from this formula, ma equals to qvb by balancing the magnetic force with the mechanical force. So we get the value of a as qvb upon m. Now this q upon m ratio is given to us in this problem as 1 into 10 to the power 8. The velocity of the particular charge carrier, that is proton, the charge carrier proton, the velocity is we have calculated as 4 into 10 to the power 6, and the magnetic field is given as 2 millitesla. So this is 2 into 10 to the power minus 3 tesla, and the mass, this particular ratio we have taken so that there is no need of mass. We have calculated, we have put the value of q upon m. So after solving this, we get the value as 8 into 10 to the power 11 meter per second square. So this is the value of the acceleration of the proton. Actually, the situation is the proton is moving from north direction to the south direction, and the field is eastwards. So a magnetic force acts on it, and it moves due to this mechanical force. Now the C part is the radius of the path traced by the proton. So for the C part, the radius mv upon bq. Now here, this m upon q is the reciprocal of this 1 into 10 to the power 8, because this is q upon m. So we put the value 1 into 10 to the power 8 in the denominator, and v is the velocity which we have calculated earlier as 4 into 10 to the power 6, and the value of b is given as 2 into 10 to the power minus 3 tesla. So after solving this, this value comes out to be 20 meters. So the proton traces a path, a circular path of radius 20 meters. So this is the answer of the third part of the problem. So hope you understand the solution. Thank you.